Assalamu alaikum. This is the seventh lecture of Discrete Homotopy Theory. So today I will define the definition homotopy theory about graphs. Okay. So first of all, what is homotopy? I defined in also this topic in Algebraic Topology lectures series. So what is homotopy? Homotopy basically is a map from from a path or from a continuous function from f to g. Such what type of continuous function? This is h is a continuous function from x cross I to y space. Okay, such that this condition hold h of x comma 0, we will get the first path f, and h of dash comma 1, we will get g according to the definition I defined this topic in previous in algebraic topology lecture series. Okay, so let's define homotopy theory of graphs for graphs. This definition, homotopy theory for continuous spaces, let's say topological spaces as well, another spaces. So this homotopy theory for graphs. Okay, so let's say two distinct paths or graph maps from x to y, where x and y are graphs, are adjacent. Two distinct paths f and g are adjacent in the graph home tensor x cross x comma y. What is the definition of home tensor x comma y? Basically, home tensor x comma y is a graph. What type of graph whose vertices are f comma g from x to y? Means the vertices of this graph, this whole graph, are graph maps from x to y, all the graph maps from x to y. And what is the edges in between f and g? There is edges, there is an edge between f and g, is homotopy between f and g. Okay, so this is the graph. What type of graph? The vertices of this graph is graph homomorphism between f, x and y. And what is the edges set? The set of edges between f to g, or another graph homomorphisms, are one step of homotopy. Okay, so let's continue this definition. Two distinct paths f and g from x to y are adjacent in this graph homomorphism, graph home tensor x comma y, if and only if there exists a map. What type of map? This is a graph map from I1 to home tensor x comma y, such that if we substitute in the place of I is equal to 0, we will get the f. If we substitute 1 in the place of I, we will get g. Okay, or equivalently, a graph map x box product with I1 to y, such that if we substitute 0 in the place of I for all for all x belongs to x, we will get f. And if we substitute in the place of this t is equal to 1 for all x belongs to x, we will get g. Okay, so let's define. This is the one-step homotopy. Okay, this is the one-step homotopy definition. This is the one-step homotopy. We can say one-step homotopy. Now let's define the n-step homotopy definition. Let x and y be two graphs where f comma g are the graph maps from x to y. So let's define for finite length or infinite length. So first of all, we define finite for finite length. And a homotopy H is a graph map from F graph homomorphism to G graph homomorphism of a length n, means finite length graph map is a graph map H. What type of graph map? X box product with in to y, such that if we substitute in the place of t is equal to 0, so we will get f for all x belongs to x. And if we substitute in the place of t is equal to, sorry, this is n. If we substitute in the place of t is equal to n in the last step, we will get g. Okay, So we can say F and G are homotopic, a homotopic. Okay, F and G are a homotopic of n step a homotopic. So this is another definition. An a homotopy between F and G, H from F to G of length infinity. This is infinite length graph map. Let's define. So H from X box product with I infinity to Y if there exist two integers n minus and n plus belongs to integers such that if we substitute H dash of I is equal to F if for all I is less than this integer, and if H dash of I, we will get G if for all I is greater than or equal to n plus integer. Okay, so we will meet inshallah next video. Allah Hafiz.